All right, so on Friday, we spent some time getting all of the tests running and writing a few tests. And there were still some questions when we finished up. But over the weekend, James and Bart both worked on this, and we were able to get some of the problems um, cleared up and solved. So I just wanted to walk through a little bit of how we did that and start with the karma.config file. So one of the things that we did so that we could make debugging of the tests a little bit easier was we pulled out the coverage code. Rather, James pulled out the coverage code to simplify that. I refactored it just a little bit so that just to clean up the test config file a little. You can see right here with reporters.push coverage, that pushes the coverage if somebody specifies coverage on the command line when they run the tests. And then down below, if we're running the coverage tests, then we also change the configuration and we add the Istanbul instrumenter. And then we set up this coverage reporter in the configuration right before we call config.set to configure all those values. All right, so a couple other things. Added a couple of timeouts, added colors. You can change the port. I put it in here. This is the default port, but if you happen to want to run the test on a different port, you can change it. And let's see. Oh, one other thing that I changed was I changed from the dots reporter to the spec reporter. And this is a library that you install. But the benefit is that your tests now look like this. So we can see index, and here's the test. Not found, and here's the test, which looks much better than the big pile of garbage that was being output before, where you really couldn't find where the test that failed was. All right, so now let's take a look at some of the actual tests. So we were working on this register component to ensure that all of these validations were correctly firing and that the form could be submitted and that the validations did their job. One of the problems that we had was we couldn't seem to set the value of the text fields. Now typically what you want to be able to do is use the React test tools. So you would call test tools simulate change, and then you would give it the input. And then after that, you would give it a value and whatnot. They have it out in their documentation, but something like this. We found that that didn't work. Again, it's probably did not work because we are using Material UI. So instead, what we found was you can just call, after finding that input by its tag within side of the Material UI component, you can call get DOM node and just set a value. And it just so happens that that works just fine. So that solves our problem with being able to set the value of an input field. The blur event does work, and that trickles up and fires. So then we can test that after entering a valid email, for example right here, the text field no longer has this error and it doesn't have the invalid email message hanging out there anymore. Let's see, there was one other one right here. So Bart went ahead and wrote the submit form test. So you can see right here we're getting pointers to basically all of the different pieces that make up that form. We're setting a valid email. Well, we're actually not setting any value. We're just setting, no, we're setting the value from this object, sorry, so that we can then use it down here. So we create this object here. We set an email, password, and here's the confirm password. And then we can call this spy on user actions. So the user actions object is the thing that gets called when the register component successfully submits. So then we submit the form here, and then we expect that the user actions register method was called with the values present in this object right here. And we could have just hard-coded the values from that object. We could have put an email and a password, but it's nice to have it contained in an object here that we can use for the duration of the test.
How are you able to get that spy on function available?
So let's see here. Spy on comes from.
Because that's what we started doing, David and I, but that's why we started looking at that React. What was that library we were looking at?
So did the spy on method just straight out of Jasmine just not work?
Yeah, it wasn't working for what we were trying to do. Are they watching a different function?
So they are watching the register action. The user's actions object is a singleton. Oh, come on.
Oh, we were trying to watch class method.
You might have been trying to watch an instance, a method on an instance.
Right.
And that, I mean, it should still work. It's just getting a pointer, basically a reference to that instance, could be the difficult thing.
Right.
And so I think what he did was he went around that and just said, this thing's register should get called. And you can see that here because here's the register method on this object that's just exported the action. So I guess he worked around it is how he managed to get it to work. But so spy on is built into Jasmine. Here's
because I thought we were attempting to do essentially that, David. But we must have just said something not quite right.
Yeah, it's really touchy, and I think that as we write more of these, it will become second nature, and you kind of subconsciously avoid the pitfalls. You learn what doesn't work, and then that somehow gets stored in your subconscious, and you just don't write code that way anymore. But while you're learning it, I have that same problem. You go and you use a method that looks like it works. Everybody else uses it. It works in the documentation, but it doesn't work for you. And then you find out it was because you were trying to spy on something that you didn't actually have access to. Or like up here when we were trying to set the value on the text fields, the test utils simulate.change is what you see in all of the React documentation. It's what you see out on Stack Overflow.
Yeah.
But it just didn't work. And
well, I would expect you too to instead of, I guess you could set it like that, but you could also call the function value, right?
Call the function.
Isn't that how you I guess maybe that's a jQuery thing.
This is just straight up HTML. So get DOM node just gives me the actual DOM node, and it just sets value.
Yeah.
So this is kind of a sucky way to have to do the test, because really you want it to behave as if a user were doing it.
Right.
That's why ideally you would do the testutils.simulate.change.
Right.
But if it doesn't work, it doesn't work. And so this is kind of our hack to get around it.
Yeah.
But the nice thing is that the tests do run and they look pretty, and now we can actually move forward with writing components that have real tests, and we can have some assurance that they function the way that we expect.
Cool.
So yeah. Do you guys have any questions about that? Did I go through that too fast, or does that make sense?
What does the new reporter look like on a failed test?
Well, let's find out. Let's say let's go pick one of these up here. To be, I can't remember if to be null.
You can do not.
Oh, that's right. We want
just do not right before the.
Not to be.
Which is a strange syntax, right? Because how the heck does that actually work? Is it just define a symbol that has a dot in it?
That's a good question. I'm not entirely sure how they made that work. No. See, we keep losing the browser. So if you see this message when you're running your tests, it's disconnected, no captured browser. Basically, you got to start over because your browser died on you. So there we go. It's executing the tests now. And we get a failure. So you can see that scrolling up. outputs the entire object, which is an enormous object because it's the index page. Yeah, ran out of buffer. Okay, so yeah, so it expected this huge object of stuff to not be defined, but it was, and so the test failed. So that's what a failure would look like. And then you get this output 1 failed. If you get this specific problem, at least it points you to the right place, register spec, line 32, and then I can come in here and I can say, okay, go to line 32, and yeah, it's not the right line. That's great. Why did it fail? Maybe it did. It fails right here. Is that right? Line 32. Why is it off? It must be...
No.
It's probably these 2 lines right here at the top that throw off the line numbering or something. So it's really line 34 that fails. Wait a minute. No, it's not. That's not even close. What the crap?
Yeah, it should have failed before you even got. Should have bailed out before it got
failed right there. Okay. So I still don't know how it figures out the line numbers. Maybe there's more stuff. Maybe all of this, because this has to run through the transpiler, maybe that messes up the line numbering.
Is it maybe failing when it tries to insert something or check that something exists in a null object?
Well, it should fail right here because we made it fail. Like we put a not in here, and so that's the failing test. It's just that when a test fails, you really want to be able to pinpoint where it failed. You want to find that spot in the code. And so whenever you get an error message like this, so say, it was 6 months from now, and then I ran this test, and this thing failed. Like it's been working, all of a sudden it fails, and you're like, oh, something broke. I must have done something. So I want to see what it is that I broke. So I want to be able to come look at this line, and it's going to say, oh, line 32. And I'm going to go to line 32, which is down here, and I'll be like, there's nothing there. What the heck is going on? And then it could have been any of these, well, it could have been any of these expect lines right here that actually failed. So who knows? I guess what we could do to clean this up a little bit is we could separate these out into different tests. So, let's just do that really quickly. If I move these out, let's make this still fail, and let's see if that gets us any closer to the right line. Now, see, it's still saying 32, and maybe I just need to start the tests over again to get it to find the correct line. Nope, still thinks it's on line 32.
Well, by gosh.
So it's still, like, it's not even pointing at the right test at that point.
Has it got something cached? What could be cached?
I don't think so, because if I fix the test, then it runs correctly. Let's go make one of these other ones fail. Let's make that guy fail. So then it dumps out all of the, here's your incorrect. And it says line 39. This is right here. So it's still not finding, I think it just...
It's got an offset of 9 lines that it doesn't know.
Yeah.
Can you put import statements at the bottom?
I think so. Let's try. Let's get rid of this. Now everything's going to do it. I don't know what that'll do. Okay, so it seems to run, so maybe we can. And let's say not. And it fails. At least they're still running. And it says line 27, which is
no,
still not the right place. Where is this coming from? Why is it not? Okay, well, so it looks like there's something that somebody can go research and figure out why The line numbering is off.
And it seemed like it was different too, because before it was 9 lines off. Now it's, let's see how many lines off. So I don't think it was 9. It was 4 lines off now.
Yeah, so what did it say? 27? Yeah, let's put it back. So it was this guy, and it said 27, so it was, what, 6 lines off?
6 lines off. So it must be doing like you're saying, where it's doing some kind of
You know what?
obfuscation on the code or something before it actually.
Not necessarily. I went and changed line 92, took off the knot, and or 91, took off the knot, and it says line 92 fails.
Line 92. Huh. And that one will give us line 32 failed, right? Yep. You know, it could be, like I say, because this is not the only thing that is going to be affected by a transpiler. These lets are also going to be affected by it. If I don't know exactly what this transpiler is doing, but I know that a lot of them will wrap the let in a try-catch block, because let has block level scope, and that's the only way they have to do it in ES5 is to wrap it in a try-catch.
Try-catch is block level.
Yeah. Because otherwise, you know, if I do var, then it's function level, which actually doesn't really matter because they're already at the function level. So we could change all these and see if that makes a difference. Let's. But maybe what we really need to do is figure out if there is some configuration you can do on your tests, if you're writing your tests using ES6, to get your line numbering to come out right. Run. Oh, I got to make one fail. So let's do this guy. All right, so now it's saying line 27. Still not right. Okay. Don't know. So the beauty is that our tests are functioning now. We can write tests, which means we'll write better code. The bad news is that the line numbers aren't right. But I did get this. Like, this is a major step in the right direction, I think. Because then when one of these tests fails, you could, at least you could just search for the text for the one that failed. Well, could you? I'll bet in this case it would actually be difficult because the line that says it failed is probably up above this huge block of junk, which you can't even get to because it's so enormous that, I mean, I could increase my buffer size on my terminal.